other example. Do red. Okay, so let's say we want to find, again, we're still doing y equals mx plus b. And we want to use a table this time. So let's say we have a table and our x values are something like, I don't know, we'll just start at -2, 0, 2, and 4. And our y values are 3, 6, 9, 12. Okay. We do need to check to make sure that this is a linear relationship, meaning that is our change in x the same every time, and for the same change in x is our change in y the same every time. I'm not as worried about that right now as just trying to we're just going to assume this is linear. So unless they ask you to check to see if it's linear, just assume that it's linear. Okay, so y equals mx plus b, that's the change in, we need to find our slope and we need to find our y-intercept, both of which are pretty easy to find from this table because we have a 0 right here, which means that's our y-intercept. But what we're going to do is we're going to look at what is our change in x and what is our change in y. So our change is x. We went from -2 to 0, that's +2, +2, +2. And then our change in y, 3 to 6, that's +3, +3, +3. So our slope, remember, is just our change in our y over our change in our x. So each time our y was going up by 3 and our x was going up by 2. So m is equal to 3 over 2. And then we could just say, oh, y equals 3/2 x plus b, and we don't know what the b is, but we can plug in any of these points and solve for that. Okay, it's pretty easy to just say, well, let's plug in 0 for x and 6 for y, and we have 6 equals 3/2 times 0, which is 0, plus b, so 6 equals b, and our final equation is y equals 3/2 x plus 6, meaning we can find any other point on this line using this equation. So if I plugged in 6, that would be 9 plus 6 would be 15, so my next number would be 15. Okay, hopefully that helps. That's how you do it from a table. Really, it's the same as what we're doing with points and with graphs. It just looks a little bit different because it's a table, but we're going through the same process. We're finding the difference in our rise divided by the difference in our run, and then finding where it crosses the y-intercept.